Hello, welcome to our channel for statistics with rprogramming. In this video, we will show how to implement hypergeometric distribution in R. So first, we will introduce briefly hypergeometric distribution. So hypergeometric distribution is an statistical experiment which takes in small capitalized, lower capitalized alphabet n from capitalized n items. So where in these n items there is k items labeled failures. So hypergeometric distribution will measure the probability of X success. Here success also means, for example, failure. So we select total small alphabet n from n items where X of this n are of these k items labeled failure. So this random variable X is called hypergeometric random variable. And this is a discrete distribution, and the probability for hypergeometric distribution is H, X, N, and K. So where K is K items are success or failure or kind of interested items of these N, total N items, where X belongs to this N. So we select n from n, right? And where X are of this K type of interest. So probability of this distribution is the division in the denominator is the combination of n, which means we select n items from these total n items. And the numerator is the product of two parts. The first part is a combination of kx, because you will select x items from k, right? And the second part is n minus k of x, n minus x combination, because we will select not failures items n minus x from n minus k. And the mean of this division is nk divided by n, and the variance is a long part of this product. So because hypergeometric distribution is a non-repeated experiment, right? Because we select item by item and not put back, so the probability of select the next part becomes the failure or becomes the success is different from item by item. But when n is very small compared with n, for example, we select only 10 elements total from 10,000 elements. So in this case, hypergeometric distribution can be approximated by a binomial distribution. So binomial distribution has a constant success rate. So in a case, n is very small compared with n, so we can think there is a constant success rate, because you select 1, 2, 3, 4, 5 from this 10,000, it will not change the next item's probability or become success or become failure. So next, we will talk about how to do hypergeometric distribution in R programming. So for the R programming, probability functions take the form of dpqr and a distribution abbreviation. So what does this mean? So dpqr means we will select one of these 4 alphabets, then plus and distribution abbreviation. And these 4 alphabets means D for density or probability, P for the cumulative distribution, Q for the quantile function. Quantile is the same as the random variable. This is same meaning, just two notion. And R means random number generation. In hypergeometric distribution, the distribution's abbreviation is hyper. So next we will show how to use these functions in R. So we open RStudio. We will show examples based on taking n items from total n, right? So here we just describe x represents the number of white ball. So the example is take a ball out from total n ball, and x represents the of white ball. M be the number of white balls in n. So this is m white balls in n, and n is the number of black balls in n. So in this example, n plus n is like how many the capitalized n, right? So how many number of white ball and how many number of black ball in n. This we plus together will get the capitalized n in the formula, right? And k is the number of balls drawn from the n. K is the small letter n in formula we have shown. Okay, so specify x values for the hyperfunction. So we create a vector using seq from 0 to 20. So this vector from 0 to 20, integer number. Next, we can apply a function d hyper. We'll calculate the density or probability of x hyper. X hyper is a vector. So we will calculate the probability for selecting different number of success in this trial. This trial is, the total number is 45 plus 30 from this n elements, total elements, the 75. And we select the 20, right? Select the 20. And we will measure how the probability of this different number of x success. Then we run. Then we plot this probability vector. So you can see the probability for the possible value is from 0 to 20, right? Because you only select 20 items. So maximum you can get a 20 success because there is 45 total white ball in the n, right? You can see about 12 or 13 number success is the highest, about 0.20 probability, right? Next, we will show how to use cumulative probability. We also create this vector for 0 to 20, and this time we will calculate the cumulative probability for x values from lowest to the highest from 0 to 20. In this time, we select total there about 60 white balls in n, and we select 30. And there are about 40 in the 40 white balls. We will measure the probability for different numbers of white balls. So this is the cumulative probability. You can see before we get to 15, there are almost no increasing, which means the probability is quite low, almost 0. But in this part, increase very fast, right? So next function is for the quantile. The quantile operation is actually the opposite function as the cumulative probability, because quantile value measure the random variable in which at this value how much the probability of all random number below this value. So this is a quantile value. So here we will create a vector of probability first, from 0 to 1 with the gap 0.01. So this is probability vector from 0 to 1. Next, we use qhyper function to calculate the quantile value associated with this cumulative probability. In example, is there total 70 balls with 50 white balls, and we select 30 balls, and we measure the quantile value for white balls from this given probability. Then we can show this figure. So now you can see the x values is 0 to 100, which means that 0 to 100 is the value of probability between 0 and 1. So when the cumulative probability increased, this integer number for the positive for the white ball selected will also be increased. This figure is actually the result of the opposite. We change x and y axis from the cumulative function, right? And the last function we will show is for the random number generation. First, we set a seed for 100. If you can run again, we get the same result. And we set the n number. We select n random number from such experiment. And our hyperfunction will generate 10,000 number from this trial. This trial is total 70 ball with 50 white balls, and we select 30. We will take 30 balls from these 70 balls, and n different numbers for white balls will be selected. And we plot this vector of 10,000 numbers. So you can see about 21 ball, 22 ball, a very high probability, high counts frequency, right? About 2,000 times, over 2,000 times will be get. So they are about 0.20% in probability for these two values, right? So 30 balls selected from 70 balls, where 50 are white balls. So about over 40%, the probability there will be about 21 or 22 white balls of these 30 balls selected, right? And you can also go to this link to download the source files for this playlist for rprogramming for statistics, and most of the videos will be uploaded later on YouTube. Thanks for watching.